Welcome to EF5 Training, Module 2.1 from the University of Oklahoma Hydrometeorology and Remote Sensing Group. My name is Laura Labriola. Thank you for joining me. This module will be precipitation forcing using a numerical weather prediction model. So during this presentation, we'll go over what numerical weather prediction models are. We'll go over the GFS. We'll talk about EF5 and how it uses numerical weather prediction models. And then we'll actually prepare EF5 to use an NWP. So far in these trainings, we've been using observed precipitation using TRIM to see how well the simulation compares to the observations. However, now we're going to learn the advantages of incorporating numerical weather prediction models in addition to the observational precipitation, what we've been using, or TRIM. So a little bit of background of numerical weather prediction. It's a method of forecasting the weather using observations of weather and equations that describe relevant physical processes. So what it does is that it uses current observations of weather and it uses computer models to simulate what may happen. Usually the typical outputs include temperatures, dew point, mean sea level pressure, winds that are surface and aloft, cloud cover, precipitation and different types of it, and severe weather indices, CAPE and helicity. And there are different types of models. There are short-range models, there are long-range models, and one that we'll be focusing on is the GFS, which is the Global Forecast Systems. So the GFS can be short, medium, and long-range model that forecasts as soon as 6 hours to 384 hours. The GFS has 64 layers throughout the depth of the atmosphere, and it has a horizontal resolution of 30 kilometers, and that's just through 180 hours. There's also 13-kilometer grid spacing equivalent over the first 10 days in the model forecast, and then it goes to 35 kilometers from days 10 to 16. This runs from the northern hemisphere and southern hemisphere, and that allows for skill at wave pattern and overall jet stream flow. The products of GFS include speeds, vertical velocity and vorticity products, temperature fields, humidity and moisture, thickness and precipitation, or QPF, which is quantitative precipitation forecast, which is what we will be focusing on this presentation. It also includes instability and shear fields. So why should we use NWPs in EF5? Forecasting precipitation has several advantages. We can use it for drought monitoring and forecasting. We can use it for agricultural drought to see if there's going to be enough water to grow crops. We can use it for flood monitoring and forecasting. And we can use this for landslide forecasting. So now if you go ahead on your computer, you can look at the GFS forecast that we've supplied for you today. So you can start in your GFS directory, which is in the EF5 Advanced folder. You'll go into Examples. You go into Nozoya. You'll go into that precip, and then you'll see GFS. If you go ahead and double-click on that, you'll see that there's one subfolder that has the year, month, day, _ hour format. So the folder name is the date that the run was initialized. So for example, this subfolder was initialized on May 13th, 2016 at 00 UTC. So you'll go ahead and click on that folder. So you'll see there are about 33 items in that folder, and they range from May 13th at 03 UTC every 3 hours until May 17th at 03 UTC. And each file in this folder is TIFF, and you can use that in EF5 as well as in QGIS. So if we go back in time and say that May 13, 2016 at 00 UTC, let's see how the GFS model can forecast the stream flow to be in the next 3 days. So for this example, we'll be using the DEM, FAC, and FDR that we created in the basic, which we created in the previous training for distributed parameters. We'll be using trim precipitation forcing up until May 13th. And then from then, we'll be using GFS forecasting. We'll also be using parameters for crest and kinematic wave. So go ahead and navigate to your preset forcing example folder, which is in your Nazoya folder. First, we're going to review how to set up your control text file to include this additional precipitation forcing for the numerical weather prediction model. So the control file on the right is the one that is used for this example. We have basic, which is the basic block, and it shows where the basic files are relative to the control text file. We have our preset forcing block, we have our PET forcing, and we have our gauge. But now we've included a second preset forcing block, one that's called trim, and then one that's called GFS. So EF5 allows for a second preset forcing block, which is primarily used for NWP precipitation forcings. When you set up your control text file for using an NWP input, you need to make sure to do 2 things. You need to enter the NWP as its own input preset forcing block, and then you need to account for this in your simulation or your task block. So in the example to the right in our control file, we have our trim, which we've usually have done, and then we have a second preset forcing for GFS. And for this, we have different units as well as the different location for where the precipitation forcing is recorded. We also have the different name format. So you need to make sure that these, when you include your own NWP, that you have it match up to the files that you want to use. So the first thing we need to do is we're going to enter the NWP as its own input preset forcing block. So in this example, we kept the preset forcing for trim as it always is. And then right below it, we have the NWP input forcing. So we named it for GFS. We put the type of file that it is. We put the units of it. We put frequency, which is also 3 hours. That matches with the trim. We also have the location of it and the name. So the important part, this next part is very important because we need to make sure that our task block knows we have this extra preset forcing block. So the way we can do this is that we go into our Run Nazoya task block, and we make sure that we're running a simulation. We make sure that we're running the model that we want to. And in this case, we're running the crest model. We're using kinematic wave for routing, and then we're using it over the Nazoya River Basin. What's important is that we have 2 precip lines now. Our first precip is equal to trim. Then we have a new line that's called precip forecast. And this is where it takes the information from our second precip forcing block. And in this case, this one's called GFS because that matches the block that we named our second precip forcing block as. So you can go ahead and run this example now since we've already made the edits in the control text file, and then wait for EF5 to finish. I'll follow along on my computer to join you. So we're in our preset forcing example folder. And you can go ahead and double-click Run EF5 batch file. So what it will do is it's going to run from January 1st, 2016, all the way through where the GFS ends on May 17th. We'll go ahead and exit out because it finished. And we'll go into our output. So we'll see we have ts.rhomba.crest. So we'll double click on it. And we put the output for May 11th all the way to May 16th. And we can see for precip, if we look in our precip column, which is D, we have precipitation after May 13th. So the NWP was saying that it was going to rain after our observation time. And we can show that this was working because if you go into your precip forcing example and then to Nazoya, if you look in your precip folder, we only have trim values all the way to May 13th. So what happened is that the model, we ran out of trim files, and so it was able to gather the GFS files from after May 13th, 00 UTC. Thank you for joining us for the precipitation forcing example, module 2.1. Please join us for our next example, which is inundation modeling.